We're here today with a Porsche Cayenne. This one is a 2004 and it is the 9PA model turbo engine. And this one has a battery drain. So the story I was given was this owner has run through quite a number of batteries. I think 4 or 5 batteries, and he changes a battery every 4 months. And it's been quite a headache for him, and he's just tired of it and he wants it sorted out. I came to do a preliminary diagnosis, and this is my first Porsche, first of all, to do. I've never done any of these, but like I always tell people, cars are cars as long as you have the wiring diagram and the service information, you can diagnose them. Now, I will tell you why we have all these panels out. So the driver's seat is out and the passenger seat is out. So the passenger seat was because the battery lives under the passenger seat, and I had a hard time trying to diagnose with that seat kept falling on my head. So I told these guys, I'm done with that. I want that seat removed. And then when I did a preliminary diagnosis, I found out that there was a module here that I needed access to. So I told them to remove also the driver's seat. I had a hard time on my first day. This is day 2. And let me run you through the issues I had on day 1 while trying to get this thing sorted. It was pretty frustrating. First of all, the Porsche wiring diagrams are crazy to read. They are worse than the Mercedes diagrams. They are the worst that I've ever seen so far, and I thought Mercedes was really bad. And it took me quite a while to find out how to navigate around the diagrams, so that wasted my time. Second thing is, Porsche call different things differently, and it trips you up. For example, that right there is not called a radio. In Porsche world, this is called a PCM. In normal cars, a PCM is the powertrain control module, but this one is actually the Porsche Communications Management System. So it's called a PCM. And it was just things like that that just kept wasting my time. I would look for something, it's called something different in the manual, etc. So let me run you through the issues that I had on day 1. The first thing is, this thing has an internal alarm that was a pain in the butt. It kept going off. It's a very sensitive alarm. The sensors are on the driver's pillar here, and any slight motion, it would trip off the alarm, and it kept throwing off my work. So I wanted to come with a foil paper and cover this panel over here, but what I found was there is a setting inside the management that you can turn off one time for the internal alarm, but you have to keep turning it on. When you turn the key on again, it resets that. So let me quickly show you where that is. If you're ever doing any work on these, you want to turn off that internal alarm. It's pretty annoying. Okay, so I'm going to turn the key on, and let's start this car because the battery really drains quickly. Now we have a few more errors here which I was told not to bother with. So we've got a check engine light, we've got airbag, traction control, that's start-stop system, and the suspension doesn't work properly, but I was told to ignore that and strictly focus on the battery drain. And yes, I did check, it has nothing to do with any of those. So to get the alarm, you need to go to the menu, and that's the main menu in there. So you go to settings, comfort, alarm, and you need to turn off the interior and angle alarm. Now once you do that, they are off, but it is off only until you turn on that key again. immediately you key on, it resets that. So it's not meant to be a setting of once and forget. Of course, that's for security reasons, but that enabled me to proceed with my work without the internal alarm going off. So put the car off, and we are going to see how much drain the battery has when this thing goes to sleep. So what I'm going to do is come to the door, and you'll need to latch the door here like that. I need the door open because I need to access my fuse box, and you're going to do the same on the passenger side. Wait for this thing to go to sleep, and I'll show you how much drain is on the battery. Alright, the car is asleep, and this is what's happening. So you have a battery drain, but it's a fluctuating drain. If you notice, we go to 7, then we go back to 4, then 5, then 7, then 4, then 5, then 7. So it keeps cycling like that. Very interesting drain. I usually see a consistent drain, but this, believe it or not, is actually easier to trace down than a constant drain. So next thing I did was to come to the fuse panels, and that is the left and right. So this is the left fuse panel, and that's open, and there's the right fuse panel on the other side. So when I checked all these fuses, none of these fuses had a draw, but there were 3 fuses on the right that had a draw. So let's go there and I'll show you that. Alright, this is the right hand fuse panel, and how I check my drain is with my second multimeter. I put that on voltage mode. Anytime you have a current draw in a circuit, you should have voltage drop on that circuit. So you just measure the voltage drop between the 2 pins of the fuses with your current clamp, and you should see the voltage drop. So let me show you what a good one looks like. And by the way, if you see your fuses just in your hand, your multimeter will just keep going in circles. If you are in a circuit that is not drawing, and you are in there nicely like that, for example, that fuse is not drawing, you should see a solid 0 all the time. I've done this many times and it's very consistent. If now you are in there and you see any motion here or steady, then you know you're drawing. So I checked all of these, and what I found was this fuse here was drawing, this fuse was drawing, and this fuse was also drawing. So let me show you that one by one. We're going to start with this fuse here. So we are in that circuit, and look at that. Now I want you to notice that reading. You see how it's cycling? Just like our battery drain current was cycling, that's also cycling. So we are definitely drawing on that fuse, and that cyclic motion of the current is also coming from that fuse. Alright, so that's one of them. Let's go to the second fuse, and that is this one here. And you need to be careful with your ground terminal over there. You need to be careful with that ground over here. That's what happened when I touched this. So it almost damaged my lead over there. That's not an issue. So let's do that again. Now check this out. That's a steady draw. Oh, this is about to go off. Let me just reset it. Okay. Okay, so let's go there again. So we're in there, and check that out. That's a steady 9.84 millivolts steady draw. So we have a steady draw on this fuse, and we have a variable draw on this fuse. Let's look at our last fuse that was drawing, and that was this one here. There we go. And check that out. We've got another variable draw on that fuse. Cool. So we've got variable draw on that one, variable draw on this one, steady draw on that one. Now let's go to the wiring diagram and want to see what those three fuses power up. Okay, to know those fuse IDs, they are printed on the fuse panel right here. So we have a draw on fuse number 4. We have another draw on fuse number 11, and we have another draw on fuse number 36. So let's go to the wiring diagram now and see what these are. Alright, here we are in our wiring diagrams, and you'll see how crazy this is and why it wasted my time when I was here the other day. So let's go to our fuse carrier to the right, and those are our fuses. Let's zoom in and use a slider to go to the right here. Okay, now Euro diagrams. I do not know why Euro diagrams are not drawn in plain circuit diagram format. You know, the same way everyone does, the same way in physics books. Toyota, Honda, Mitsubishi, most Japanese cars, they actually draw their circuit diagrams as circuit diagrams. But Euro cars, for some reason, draw their diagrams in confusing formats. It's keyed so that you have to decrypt the key. It's coded instead of using regular wiring schematic language. They use different language. I don't know why this is done. All I can think of is it's just done to make things complicated and to waste time. There's no other reason. In fact, it's easier to draw these diagrams in proper diagram format than it is to do this stuff. Why it's done, I really don't know. So let's see how Porsche do their diagrams. So here's our fuse 4. Fuse 4 feeds these two lines here. So we're going to take our line selector and we're going to select them. So I'll select this one and I'll select this one, and then our next fuse that was drawing was fuse 11. Fuse 11 is here, so we're going to select that line, and then our last fuse that was drawing was fuse 36. So let's move to this side, and fuse 36 is here and it feeds these three lines. So let's select them. So there's a cool feature in this software, and this is not really Porsche's software, but Porsche's format is exactly like this. It's just that this software is packed with a feature you can filter. So let's filter out all our lines and leave only the ones that are selected. And let's come down here. I'm going to zoom in so we can read, and we slide this side. So our fuse here the last fuse, that is 36, feeds the compass, the roof module, and the telephone control unit. So I'm going to write that down, and then let's move to the right here, and we're going to see where our other lines are. So here is one of them. Our fuse number 11 feeds the PCM 2.1. Now this is what I was saying. This PCM is not powertrain control module like every other manufacturer calls the engine control module. This PCM is Porsche Communications Management Unit. Basically, it's just a fancy name for the display and the radio. So that is what that is. And then let's go to our first fuse, which was fuse number 4. And right here you see it feeds the telephone control module and e-box mobile phone. So our draw is between the display and the telephone control module. Now, after seeing that, that is when I told the guys I need access to the display and the telephone control module. So I told them to pull out the display for me, which is there, and to pull out the telephone, the seat, the driver's seat, because the telephone control module is under the driver's seat. Now, today we are going to do some more tests on these two modules and figure out how to solve this current draw problem. Okay, now let's go back to our wiring diagrams here. You see this? PCM 2.1 18/E8, and then we've got this code here 4007 RD/YE. So after much struggling and pain, I figured this out. This is the device that the line goes into. If you see this, it's either an input or an output. So this is going to that circuit, so that's an output. This is an input, but sometimes they are opposite, so I don't usually go with this. 18 is the circuit ID, so for example, circuit 18 is for the PCM. E8, I honestly don't know what that is, but I suspect on the original diagrams there were quadrants here. So there was a quadrant down and there was a quadrant here. So you have letters and numbers. So you have like a box. So you go letter E, number 8, something like that. I honestly don't know what else it is. Now 4007 is the line ID, and RDYE is the color of the line. So this is red and yellow. So let's go to the PCM circuit 18, and we're going to look for wire 4007. So here we have circuit 18. Here it is DVD and navigation. And we're going to zoom in. Bring our slider down, and we're going to look for circuit 4007. Line 4007, sorry. And here it is. So this is line 4007. Let's mark it up. And you can see here it comes from the fuse box, right? Fuse F11. And if we go up to the control module, see here, it's on connector A, terminal 4, and it's designated as terminal 30. So in Eurocars, terminal 30 is permanent battery power, and this is red and yellow. So what I have done is put my current clamp on that red and yellow wire on that connector, terminal number 4. That is on the picoscope channel B. So now let's go back to our fuse carrier, right? Now let's look for fuse number 4. Zoom in. And remember, it was these 2 lines. Let's mark them up. And these are control unit for the telephone. And it is 19A, and this is e-box mobile phone 19E2. Now, to know which ones we have, if we have both of these or we just have one, we need the car vehicle specifications. Remember this here? We get it just like we get it for the Volkswagen. And remember, Porsche is just a glorified Volkswagen. That's what it is. Many people don't know that. So let's go and look for telephone. So here, 3-spoke multifunction steering wheel in leather with radio and telephone control element. Look for telephone again. Telephone telematics, telephone module with passive handset. So we have the passive handset, not the mobile handset. And we have another one. That's it. So we do not have the mobile handset. Let's just search for mobile just to be sure. No. Okay. So we go back to our wiring diagram. Now we know that we don't have this e-box mobile telephone. We have the control unit of the telephone, and that is circuit 19A. So let's go to circuit 19A. 19A telephone. Oh, and we need to look at the... Let me quickly look at the wire ID before we go over there. Let's just go back here quickly. And I can see why I said it's really a waste of time. All right, let's look at our wire ID quickly here. Our wire ID is 2705. Okay, now let's go to circuit 19A and look for line 2705. (19A). Zoom in. Let's go here. And this is 2705. Let's mark the line. And what do you see? Supply plus. And now I will save you some time, and I checked. This other supply plus here comes from the other fuse, and we can see down here. Look, we've got this coming from fuse number 4, which was drawing, and this one coming from fuse 36, which was drawing. Now there was no draw on this one, but this here is actually terminal 15. Terminal 15 in Eurocars is ignition key on voltage. So this supply plus and this supply plus is both battery voltage. Okay, so what is our wire color? We've got red and black, and we've got red and yellow. So now I have the red and black wire on this telephone module right here, and I've put my current clamp right there. So I want to monitor the current going through this module, and I want to monitor the current going through the radio module, and then we are going to make our calls based on that. So let's set up the picoscope and see what we have. Alright, so what I want to quickly verify is that we only have a draw on those 3 fuses, that there's nothing else drawing. So what I want to do is pull those 3 fuses and then go to the battery and see whether our draw goes away. The first thing I want to do is to verify that we still have our draw, because the car's been sitting for quite some time. So let's go to the other side and quickly look at our draw. And there is our draw. So we're still cycling and we're still active drawing. It's gone a bit lower, which means the car wasn't fully asleep, but now we're cycling between 480 and 230. Okay, let's go pull our fuses and come back and look at this draw. So I'm going to do this in real time. So we're going to pull fuse 4, then we're going to pull fuse 11, and we're going to pull fuse 36. There are 3 fuses down there. Let's go back. And look at that. 45 milliamps. So this confirms we fix this issue and the telephone issue. We are going to solve this draw on this car, and let's just verify that it's 45. Sometimes this drifts, so how I'm going to do that is I'm just going to lift this, put it up there, and zero it, then put it back down. Oh, that's beautiful. Look at that. 34 milliamps. That is perfect. So now we know. So now let's activate the picoscope and you see what our current draw is on those 2 lines when we put the fuses back. Alright, I've hooked up the picoscope and our channel 1 is coming down to the telephone control module. Now the telephone control module, there are 2 power lines. Remember those supply positive next to each other? One was red and yellow, one was red and black. They're both being fed by 2 fuses. So I've decided to loop this into both of them, and we're going to see whether the current is different or these are just parallel backup fail-safe power supplies. I think they are fail-safe power supplies. Then on the radio we have our channel B that is on the radio line. So the first thing I want to do is to zero the clamp. Now you need to remember, when you're dealing with low amperage, your clamps must be zeroed and left still where they are supposed to be, so we don't move them. So both of them are zeroed. So we're going to start with inserting the radio fuse. So that is fuse 11 on the radio line. So there we go. And that is the radio. You can hear the CD. That's the CD changer going. And then it settles there. So we are settling down at 250 milliamps, and I have left this for about 30 minutes, and that 250 doesn't go down. In fact, what happens is sometimes that spools up again on the changer, the CD changer, and it spikes up and then comes back down just like what it did. All right, so that is the radio line. All right, now we're going to go to the next fuse for the telephone control unit. First slot is fuse number 4. There it is. Now that telephone control unit is the one that has the variable voltage on it, variable current. So it is drawing and it is variable. And this cycle continues. It goes step, step, then down, then step, step, down. This never goes away. So we have 2 independent draws, one on the telephone control unit, one on the radio, and they just keep going. So this battery, on average, this one is going to draw around at the peak here. Is drawing 460 millivolts. So the summation of that, 460 plus 250, that's 700 milliamps at the peak. Given the size of this battery, it will take roughly 48 hours to draw completely, which is about what the customer is complaining about. So how do we solve this? What can keep the telephone module from going to sleep, and what can keep the radio from going to sleep? The only other variable is this is a CAN network. These 2 are on the infotainment CAN. If our infotainment CAN is active, then it will prevent the modules from going to sleep. The infotainment CAN is the same here and here. And conveniently, it's those 2 lines right here. So let's take channel C and D and look at the CAN on the infotainment line and see if there's any CAN activity. If there's CAN activity on the infotainment line, we need to find out where the CAN activity is coming from, because that'll keep these 2 modules awake. If there's no CAN activity, then we are done. We have a bad radio and a bad telephone control module, and that is what we'll need to address. All right, so let's look for our CAN. We can look at the CAN topology, but I'm not interested in that. I am looking for the network. So let's go to the CAN network. Oh, there it is. All right, so let's go to the gateway. That's circuit 23. And we're going to zoom in. Go here, and that's our gateway. And on the gateway, we're going to look for the infotainment CAN. So here we have CAN display low, but that is for the display, which is the combination meter. Here, connector A, pin 10, we have CAN info low and CAN info high on A20. Those are our infotainment CANs. So let's mark up those lines. So we got this one here and this one here. Let's see where they go. So they splice here and they come to this. So all these are part of the infotainment CAN. So let's mark all these lines up. And we see what's connected to the infotainment CAN. So we have the wiper motor strange thing to be connected to the infotainment can. You've got the parking heater, and we've got the PCM 2.1. So the only thing that has a can is the PCM, which is this one. This guy does not have a can, but this is connected to the PCM. So what we're going to do is to come to the PCM, and we're going to look at the can high and can low at the PCM and see whether we have activity at the PCM. All right, so we have probed the can high and can low lines on channel C and D, and I have overlaid them together. You can see we're still drawing. Now let me put channels A and B off first, and I want us to discuss something here. Let's drop this time base because we're going to look at that can when it gets active. Let's do 100 milliseconds, and let me put my trigger to none. Now if you look at this, you'll see that one line is going to stay at 12 almost, and the other line is at 0. Guys, do not get confused with these infotainment cans. Porsche, Audi, Volkswagen, same architecture. The infotainment can lines are unlike regular can lines that we are used to seeing. If you recall the diagnosis I did on the gateway for the Volkswagen, I saw this thing and it confused me. Later on, I came to find out that the circuit was working fine. The infotainment can for these cars does this. In fact, if you want to see whether it is active or not, we'll just take the key and we're going to hit key on, and that infotainment can line should come on. So here's the key, and the infotainment line comes on. Now if you notice on the green, let me just pause this and I'll zoom in here. Look at the can low and can high for these. The can low comes from 12 volts down, and the can high comes from 0 volts up. So if I separate these two, that is what an infotainment can on VAG cars, Porsche, Audi, etc. looks like. This is normal. This has no problem. It will communicate fine. But our whole reason for taking this capture is to see whether there was activity on that can line that was keeping the radio on, and there was no activity on the can line. So we are done. This is a bad radio, and this is a bad telephone module. Now we have another issue. If we disconnect the radio on the telephone module, there will be no radio, but also the dashboard will not work properly, because these dashboards work with the PCM. You cannot divorce these two from each other. Let me just show you what I mean. If I put the key on, you're going to see information from the radio appearing on the dashboard. So let me start. So now let me put the radio on. So there the radio is on. And if I come here to select a channel, for example, look at that. FM radio 88.0 megahertz showing on the dashboard. This requires your PCM. So we cannot just disconnect these two and then decide we're going to put an aftermarket radio. What we need to do is to find out how to solve this problem, because these two modules are actually working. The problem is they're not going to sleep. So I have an idea, and let me go to the wiring diagram. I'll show you what my idea is. All right, here's the idea that I have. We're going to go to the telephone module again. Let's zoom in on the module, and on the telephone module we've got two supplies, supply positive here, supply positive here. So we've seen that these two are redundant supplies. They are there as a backup so that if one fails, the other one takes over. They're on two different fuses, but the module only uses one or the other. It doesn't use both at the same time. And then here we have terminal 15. Now terminal 15 is ignition key on. So what we're going to do is disconnect our supply from the fuses. So we're going to cut this line here, and then we are going to join these two supply lines to terminal 15. When we do that, this unit will only come on when the key is on. And then when you put the key on, when terminal 15 dies, the unit goes to sleep. That's my idea, because terminal 15, remember, is ignition on. So we're going to do that here. Now for the radio, it's a bit more involving. We need to get a terminal 15 on the radio. This radio only uses a permanent battery supply. There is no terminal 15 anywhere here. In fact, we can just verify that on the wiring diagram. Let's go to DVD and navigation. That is where our supply lines are found. I'm going to zoom in here, and then check this. We only have a terminal 30 and terminal 31, and in our case we don't even have terminal 31, we just have the terminal 30. There is no terminal 15 on this radio. But what I can do is this. We're going to come to the fuses. Let's go back to our fuse carrier on the right. Now, if you recall, our radio fuse is fuse 11. So let's go here to fuse 11. That is our radio fuse, and it is fed by this terminal 30, which is hot all the time. Okay? Oh, sorry, this terminal 30, which is hot all the time. But there is another fuse that I found, which is fuse 41. So let's scroll to the left here and check out fuse 41. It's right here. Let me center it a bit. This is fuse 41. Now, if I highlight it here, let's go down. You see what it serves. Coupling control unit for trailer. I can tell you, this guy does not have a trailer, nor is he the type of person to be hauling a trailer around in such an expensive car. This is what we are going to use. Because we do not have, we will never use the trailer, we are going to take this and feed our radio from this fuse instead, because this fuse is actually a terminal 15 fuse, and we can verify this like this. You see these fuses, they're all supplied here. So let's go up here, highlight that, go up, there's a splice here, we highlight this one, then we come here and go down and look, fuse box left, terminal 15. So we're going to take at the fuse box, at the back of the fuse box, we're going to expose that harness, and we're going to pull this line for the radio. We're going to cut the terminal 30 line, and then we're going to look for fuse 41 and join that line onto fuse 41. That will mean that this radio will only come on during key on. The only issue this guy will have is if he sets memory for the channels in there, or if he's playing a CD player or a memory stick and he pauses and leaves the song, let's say on track 10 or track 11, whenever he comes back, everything will reset. So he'll not be able to store radio channels, and he'll not be able to store channel info for his USB stick. Also, he will not be able to store numbers, I think, for the telephone. That's the issue. But we've talked to him about it. He doesn't care about that. He said go ahead. All he wants to do is to stop buying batteries, because he's been buying a number of batteries, and these batteries are not cheap for this car. So that's what we're going to do. Let's start with our telephone control module, and let us make it terminal 15 only. Okay, there's our first repair for the telephone control module. This is the terminal 15 line, that the black and green, and these are the two battery positive lines. So I've just bridged them together here. So you've got the three lines coming out, and then the two terminal 30 lines there, I've just blocked them off so they don't short. And I'm going to tie this harness up nicely. Alright, and that is the repair. I always finish up the end with conventional tape, because I found that tester tape at the end likes to peel off at times. So this just makes it remain secure in one place. Right, we're done with the telephone control module. Now the PCM. Okay, now for this one, how do we go about it? You can do it in two ways. You either tear down this entire panel here. So to remove this box, it cannot come out like this. The harness is too short. Neither can it go in because there's no room to push it in. So if you want to remove the fuse box, you need to remove this entire panel. You need to remove this side panel, lift this up slightly, and then you will have room to push it in. That's very involving, and it'll take quite some time. The other way of doing it is to first identify your fuse. So we're going for fuse 41. If you come here to this panel, let's see where fuse 41 is. Fuse 41 is here. So it is on the second last row. 1, 2, 3, 4th fuse. Okay, so now let's go there. That's the second last row. So that's 1, 2, 3, and 4. So this is our fuse. So what we're going to do is to pull that fuse out. Take that fuse out. Now we need to find out which side of the pins there, which side of those pins is hot. Okay, so we either have that lower side that's hot or the top side that's hot. How do we find that? We take a test light and we connect it to battery negative. So this extension is connected to the battery. So when you touch positive, our test light lights. Now we are going to start the car because we need terminal 15 on. Actually, just put the key on. And with the key on, let's come here. We need to test whether this is hot or this is hot. Now the bottom one is hot. There's my test light. So that is at the bottom pin. Okay. Now I know that my top pin is my pin that goes to my component. So what I'm going to do is come here and take a spade connector. So that type of connector. So it's a test connector on one end and it's a spade on the other. And we're going to insert it onto that top pin right there. Now here I have access to the side that goes to the load, my component, and I can easily now test with my test light. Now my test light is still connected to battery negative over there. So what I'm going to do is go on the other side and look at the wiring diagram and find out the wiring color on the other side. For this particular fuse, it is a black and blue wire. So if you go to the other side, we lower the just this panel, which is very easy. It's just one bolt over there, and we have the wires there. So I've already isolated one and show you how to get the other one. So you'll get several colors that are the same. So this is a black and blue wire right here. So I'm going to test whether that is the one. So I'm going to put a probe here and then I'll show you what to do next. Alright, so there's my probe connected to that blue and black wire, and we've access to the test point on this side of the probe. Now we're going to take another wire, and this time we're going to connect it to battery positive. So that's battery positive. And then we are going to stick this probe in here. Okay, let me remove the pin and I have that probe. So we'll stick that one inside our test point there. Now it's important to connect to battery positive and not negative. You don't want to send grounds through potential power wires over here. So remember, on this side we have our probing point. If this wire is continuous to that, we should light up our test light. And now our test light connected to battery negative still, and we're going to test our test light, and it is lit. And then we come to this side of the wire and we probe it. And it is lit. So what I know is this side is the load side for that fuse. Now it'll take you a while because there are a number of connectors here, there are a number of fuses, and there are a number of wires that are the same, but only one will light up with that combination. All right, so now that I have my two wires and I've isolated them, now let's send terminal 15 down to the radio instead of terminal 30. All right, there is our terminal 15, and it splices off to the radio. And since the trailer hitch module is not used, we're going to leave the fuse the same because it uses the same 10 amp fuse for the radio. So that circuit is capable of carrying the full 10 amps for the radio. Okay, now we're going to neatly put the insulator here, and then we neaten up that harness. All right, the repair is done, and check this out. A good repair, people should not know that you are ever there. Okay, so that is covered just like factory, and this car is good to go. So now let's test our current draw now with both our components on terminal 15, see if everything works out. All right, we're done with the repair. Let's verify it. So key on and the radio comes on. Nice. Okay, I'm going to start the car. It's working well, and we're going to put the radio on. We have audio and everything is working well. So now when we turn off the car, the radio should go off immediately. So I'm going to turn off the ignition. The radio goes off, and that's it. So now let's hook up our battery current gauge and see how much current this takes when it goes to sleep. So we're going to do the same thing. We'll trip the door, arm it, and then see how much current we have drawing. Alright, we just put off the car, and the car is on its powering down phase, and as you can see, we're already down to 222 milliamps, and it is not fluctuating anymore. So let's leave it for about 15 minutes, let it power down completely, and look at the final resting amp draw. Okay, it's been 30 minutes and bam! 30 milliamps. Beautiful. I like that. That is a fix. We are done with that Porsche 2004 Cayenne with a very stubborn battery draw. I wonder who else would have done this, you know, knowing that people don't touch Porsches around here. Well, at least this one is fixed. And just to verify, you can see the alarm is armed. We are flashing. Let me put the light off there. See that? We are armed, so that means the car is completely asleep. And just one last shot. Okay, another one for the books. Let's go see what's happening with that Tribeca. If it's a good one, I'll bring you along. But that's for another video. Until next time.